Dear Chairman, dear professors, I'm now here as the scientific advisor of the Institute of Earth Physics and Space Science, and now I'm talking as a researcher because this is also something very close to my heart, the fate of carbon dioxide. But first of all, I would like to say a few words for Laszlo Sarka, because I really think that the scientific debate is very important, even if we have sometimes very contrasting, but this is really the message for the future generations, that without getting into these scientific discussions with real data, we will never find the truth. I have the feeling sometimes that people are really fighting for demonstrate that they are right. But instead, we should all agree that we should really search for the scientific truth and not to demonstrate that we are right. And in this spirit, I would like to show you an interesting aspect that was completely abandoned in the previous talks. And as a geologist, and even worse, as a geochemist, I was a little bit saddened by that, because I feel that our profession is overlooked. Because we must understand that there is a very important factor in all of these global carbon cycle models, and this is the geological carbon dioxide emission. And as you see here, the research in the past several decades focused only on active volcanic areas like oceanic ridges, oceanic arcs, and active volcanoes, and active volcanic magma chambers. And then this was all. And we all know that these are the places where we expect geological carbon dioxide emission related to the magmatic activity. Probably it's needless to say to you, because you have images of the volcanic activity, the recent volcanic activities in the East African rift, that there is tremendous carbon dioxide emission associated with that. However, we forgot about a very important factor. And there is only one paper, and all of the modern, let's say, or recent papers refer back to this by Gerlach, and he stated, based on these active volcanoes, that the geological emission is only 0.3, 0.4 gigaton annually. Okay, it is important to remember that. And what about the anthropogenic emission? Is this 35, 40 gigaton per year, so 2 orders of magnitude more. And actually we have to somehow have a sense about these 2 orders of magnitude difference between the geological emission and the anthropogenic emission, because it seems suspicious. And how I got into this carbon dioxide debate was that with our research group, we started measuring the carbon dioxide emissions, but very far from active volcanoes, in areas of the world where we wouldn't expect any volcanic activity, but still we observed large amount of carbon dioxide coming out from the subsurface. And from scientific point of view, first it was pointed out by an excellent Italian researcher, Fresotti, that the asthenosphere, the molten part of the Earth's interior, can be a significant source of carbon dioxide. And just 4 years ago, we developed a model which shows that if the asthenosphere, let's say, cools down and the silicate melt inside crystallizes, it's a very important source of carbon dioxide, even far from active volcanoes, far from active magma chambers. So the question arises this way, that we can now clearly imagine carbon dioxide emission very far from active volcanic centers. And if we just look around in Hungary, we find a very clear examples of that in the Balaton Highland area, in Mátra-Derecske, or in the basement of the Great Hungarian Plain. Tremendous carbon dioxide is released from this depth. And this carbon dioxide has never been considered and accounted in this global budget and geological carbon dioxide emission. And just to finish off, I would like to show you very recent papers from this year, and I just highlighted one sentence from this article, which actually claims that in areas far from active volcanic activism, we might have exactly the same rate of carbon dioxide emission as in volcanically active areas, which is a very interesting statement. And also, a very recent paper, which is just before publication with our research group in the Institute, we also found that in the Balaton Highland area, over a 10 million years of time span, we had 103 gigaton carbon dioxide emission from a very small area. So basically what I would like to highlight here, that to fully understand and also to contribute highly to this debate that we are having now, is very important to have real quantitative results. So that's the reason why we placed infrared detectors in two particular sites of the Pannonian Basin. And we do hope that this way we can contribute to this debate with real numbers and also clarify how much role the carbon dioxide may play in this climate change thing. Thank you for your attention.
Thank you very much. The next comment will come from Dr. Bayer.